your Zener diode is placed like this. Simple example. And it is given that Vz of the Zener diode is nothing but 5 volts. And this is R. Let us assume my input is a 10 sine omega t signal. And you are asked to identify the output voltage, V out. And then you are asked to plot the transfer characteristics of the given circuit, as we did earlier in the normal diode clipper circuit. So as we discussed, we have 3 different cases for our Zener diode, and we don't know which mode it is operating. So we will open it. Its anode was connected to 0 volts reference, and cathode was connected to this output node. When diode is open, the right side branch is open. The downward branch is also open because diode is in open condition. There won't be any current flow through R. There won't be any drop. So this potential will be at same as your V in 10 sine omega t. And that 10 sine omega t will be oscillating between plus 10 and minus 10. Plus 10 and minus 10. So while plotting the output, we should replace the diode with a proper equivalent circuit. For that, we should understand the status of the diode. At present, if you're opening the diode, the potential here is 10 sine omega t. If 10 sine omega t is positive, the diode is reverse biased. If 10 sine omega t is negative, the diode is forward biased. So when 10 sine omega t is negative, we are sure that diode is forward biased because this is at 0 volts. This potential will be negative cathode, anode is more positive than cathode, diode is forward biased, act as a short circuit. The moment it is acting as a short circuit, output will be 0 because nothing is visible at the output. Act as a short circuit, V out equal to 0. All negative cycles, V out will be equal to 0. Why it is 0? It is acting as a forward biased short circuit switch, ideal closed switch. So V out equal to 0. Right? And since input is negative, there will be current from 0 to negative value in this direction. Its value will be equal to 0 minus 10 sine omega t divided by R. Right. If 10 sine omega t is positive, we'll have 2 options. One option is the diode will be in reverse mode before breakdown, region number 2, or reverse biased breakdown, region number 3. If it is in region number 2, it acts as an open circuit because current flowing through the diode is 0 amperes. So it is in open circuit. When it is in second mode will happen, the diode was connected like this. When 10 sine omega t value is less than the breakdown voltage, 5 volts, right? When it is open, the voltage is 10 sine omega t. If that value is less than the breakdown voltage is given as 5 volts, if that is less than 5 volts, V in is less than 5 volts negative here in this axis, but we have placed a diode with cathode up and down. So a positive signal will reverse bias the diode plus 10 sin omega t. If that reverse bias exceeds 5 volts, so I'm marking the level 5 here, exceeds the 5 volts, it will be in breakdown mode. So before that, if V in is less than positive 5 volts and greater than 0, that is in this region, red color region, input is less than 5, so diode is about to break down, but it is in stage 2 before breakdown condition. When it is before breakdown condition, it acts as an open circuit. When it is in open circuit, you can see that if this is in open circuit mode, you can see that again there is no drop across resistance R, as we discussed earlier. No drop across R implies V out is same as the input voltage. Right? V out is same as V in this region. Okay. So it will have a same shape. So input is rising from 0 to 5. Here it is coming down to 5, and this is at 5. This is 0 as we discussed. It is going up to 5, then comes down to 5. And we should know what is happening if V in goes beyond 5 volts. If V in goes beyond 5 volts, this voltage will become more than 5 volts. That breaks your diode in the reverse mode with cathode positive, anode negative 5 volts. So you can replace your diode with a 5 volts source once it is in breakdown mode, third region, right? So once V out is shunted by a 5 volt source, V out will be always 5 volts. So V out remains at 5 volts when input is greater than 5 volts, and this is my 5 volts level. So based on 3 different modes of operation, region 1, region 2 and region 3. Region 1 output is 0, 0. Region 2 V out equal to V in, same shape. Region 3 in breakdown mode, V out is flat, constant, positive 5 volts. So the waveform will look like the waveform shown here. This is omega t axis. And if it is in breakdown mode, you are applying 10 sin omega t and you are getting only 5 volts here. And the remaining voltage, 10 sin omega t minus 5, 10 sin omega t minus 5 will be dropping across the resistance R in this polarity during this region if V in is greater than 5. And there will be a current in this direction from cathode to anode once it is in breakdown mode, as we discussed in our VI characteristics. The remaining voltage will drop across R. So while coming to the transfer characteristics, once you have the output waveform, you can easily draw the transfer characteristics. First, you should note that your input is varying between -10 to +10 because it is a 10 sin omega t signal. When it is negative, V out equal to 0. When V in is negative, V out should be 0 volts. So this will be flat. For different negative values of V in, V out is always 0. When V in is greater than 0 and less than 5, it acts as an open circuit. So V out equal to V in, because there is no drop across the resistance. When it is open, V out equal to V in. V out equal to V in curve will look like a linear curve, straight line with slope equal to 1. Slope equal to 1. Once V in crosses 5 volts and can go up to 10 volts in this particular example, V out is clipped, and that level of clipping is nothing but 5 volts. So this circuit actually clips the negative portion of the input waveform plus all the portion with a V in greater than 5. Here slope will be 0. So your Zener diode will be operating in forward biased mode here, reverse before breakdown here, reverse and breakdown mode in the third portion of your transfer characteristics. Input waveform, output waveform, transfer characteristics. In the examination, they will give you the circuit and 4 transfer characteristics. You have to identify the correct one, or the other way. They will give you the transfer characteristics. You should identify correct circuit among the 4 given circuit, or they will give you the circuit with input waveform and 4 options as output waveforms. You have to identify the output waveform, right? So input output waveforms, transfer characteristics, and analyze of the circuit. We are opening the diode first, then we are identifying the different modes, then we are replacing the diode accordingly, either short, open, or with a voltage source. You should be careful while drawing the voltage source. Cathode is positive, then anode with a VZ value. VZ is the reverse breakdown voltage, VBR or VZ. So this is called a shunt clipper because the diode was present in parallel with output, shunt clipper, and you have 2 different slopes, S0 here, S0 here, and S equal to 1 in the linear region. All right, let us interchange the position of diode and a resistor. Let me draw my diode like this, and resistance comes across V out. This is V in, as we discussed, 10 sin omega t. And this is my V out. Again, the Zener diode with VZ equal to say 5 volts. This is the resistance R. You are asked to identify the output waveform for a given input waveform. It's a sinusoidal waveform oscillating between plus 10 and minus 10 sin omega. And you have to plot the transfer characteristics also. V out on the y-axis, V in on the x-axis. And the diode appears in series between the input and output, so we'll call it as a series clipper, right? Again, before analyzing the circuit, we will open the diode. The cathode voltage is nothing but 10 sin omega t, it's clear. Anode voltage is nothing but right side open, left side is also open, no current flow through R, no drop across R. So same 0 volts will be appearing at the anode terminal. So if 10 sin omega t or V in, if 10 sin omega t or V in is less than 0, your diode is forward biased because this is less positive than anode, because anode side is positive 0 volts and cathode is negative. So anode to cathode is positive, diode is forward biased. Act as a short circuit, right? So when this is acting as a short circuit, V out and V in are same. V out is equal to V in. V out is equal to V in. So in your output curve, if V in is less than 0, that is the case here, diode is forward biased acting as a short circuit. V out is same as V in. V in. ഞാൻ audible ആണല്ലോ അല്ലേ? ഒന്ന് ചാറ്റിൻ്റെ പറഞ്ഞു ഓക്കെ ആണല്ലോ, ഞാൻ ചാറ്റിൻ്റെ നോക്കില്ല, റൈറ്റ്. ഓക്കെ, താങ്ക് യു. ലെറ്റ് us continue. V out equal to V in when V in is less than 0. So my output signal will be same as my input signal when V in is less than 0 or 10 sin omega t is less than 0 or 10 sin omega t is negative. And if my V in sin omega t is positive, of course the diode will be reverse biased. Why it is reverse biased? Anode voltage is 0 volts and cathode voltage is positive sin 10 sin omega t. Talking about positive absolute. There I will have two different cases: reverse bias before breakdown and reverse bias after breakdown. So the moment 10 sin omega t is less than 5, it's my 5 volt level, 5. If it is less than 5, it will be in reverse bias and it is in before breakdown region, because you should cross a 5 volts in reverse direction to break the diode in the reverse mode. So before breakdown, so it acts as a open circuit, right? So if 10 sin omega t is greater than 0, right, and less than 5 volts, it is in reverse biased before breakdown mode, act as an open circuit. Once it is open circuit, there is no branch current through R, 0 volts, V out also will be equal to 0 volts. Implies V out equal to 0 volts. So when your input is between 0 to 5 at either ends, 0 to 5, V out is 0, right? V out is 0. When input is in this region greater than 5 and greater than 5, less than 10, it is in reverse bias mode and it breaks down. The diode breaks down, right? Once the diode breaks down, you can replace with, diode was connected like this. You can replace your diode with VZ value with the cathode positive, here positive, anode negative. X value will be 5 volts, right? So it acts as an ideal voltage source. Ideal voltage source. And what about V out? V in is positive greater than 5. Greater than 5. What about V out? V out is nothing but if you are writing Kirchhoff voltage law around the loop, if this signal is a general variable, let us mark it as V in itself, and with a positive negative polarity. So negative positive starting from ground, negative positive plus V out, negative positive plus 5, positive negative minus V in equal to 0. Or V out is nothing but taking V into the right hand side, V in minus 5. It's obvious that negative pole is connected to the output side. So you're subtracting actually 5 volts from the input. And this happens when V in is greater than 5 or V in is positive in this polarity. Right? So you're subtracting 5 volts from 10 sin omega t, right? So V out is nothing but 10 sin omega t was your input minus 5. So if instantaneous value is 5, this value is 5. You are subtracting 5 from 5, you'll get a 0. If you are concentrating on the peak, instantaneous value is plus 10 minus 5, you will get a plus 5. Positive 5 peak for the output. If you are subtracting a DC value or adding a DC value from a sinusoidal voltage, the shape of that voltage won't be changing. So it preserves the shape as sinusoidal itself, and peak value is nothing but plus 5, negative peak is nothing but minus 10 for a 10 sin omega t. Right? So in the given circuit, they will ask you to identify the maximum and minimum value of the output voltage. It is clear that V out equal to V in when the diode is forward biased. For that, V in should be negative. V out equal to V in implies negative peak of the input will be the negative peak of the output. That is nothing but minus 10. And positive peak occurs when input is at positive maximum. When input is at positive maximum, here in this example, Zener diode breaks down. You have to subtract 5 volts from the input signal because the diode was connected like this. Right? So positive maximum for the input is 10. If you're subtracting 5, 10 minus 5, the positive maximum will be 5%. So the circuit will produce a maximum value plus 5 at the output, minimum value minus 10 at the output. Then we have to plot the transfer characteristics. Actually, based on the transfer characteristics, you can easily identify the output waveform and the operation of the circuit or status of your Zener diode. So once your transfer characteristics are ready, everything else can be evaluated. Right? So we are varying from input from minus 10 to plus 10. As we discussed, when input is negative, V out is same as my V in, right? V out is same as my V in. So slope will be 1, passes through origin, and input is limited by minus 10 volts. When input is positive, and if that is less than 5 volts, the diode is reverse biased. This becomes open, no connection between input and output. Drop across R will be the output voltage, drop across R will be 0 volts. So output will be 0 when input is between 0 to 5. Clear. When input is greater than 5 volts, you can easily write your V out as input V in minus 5, because Zener diode was connected like this. It is in breakdown mode. When V in is greater than 5, then it is replaced with a positive negative 5 volts. So you have to subtract 5 from V in. And we are talking about positive values of V in. So this is of the form, this equation is of the form y equals mx plus c. Y is my V out on the y axis. V in is my x on the x axis. M is the slope, so slope will be 1 here in this case. Y intercept is c, its value will be at minus 5. So a linear curve straight line passing through 5 and minus 5 with a slope of 1. So it is valid if and only if V in is greater than 5 volts. So the straight line will start from 5 and goes linearly as input goes up. And if you are extending this, it will cross at minus 5. Right? So in this example, you have S equal to 1 region here and here, slope equal to 1. And first part of the transfer characteristics passes through origin. Second is a flat with slope equal to 0. Third one is of having a slope 1 and it never passes through origin. It has a y-intercept of minus 1. So transfer characteristics, input and output waveform. If you are connecting your diode the other way, the only thing is that it will be forward biased when input is positive. If you are connecting the diode the other way, input is if input is positive, if you are connecting your diode like this with the resistance here, if your input is positive, diode turns on. So V out is equal to V in for a positive values of V in. Get a curve like this. This is my V out. Then if Vz is nothing but 5, so if it is less than minus 5, it breaks down. Here it breaks down. And from 0 to minus 5, it is in reverse mode before breakdown. Current equal to 0. This branch current equal to 0, diode act as an open circuit. So drop across this resistance will be 0 as we discussed earlier. V out will be 0, 0. And if your V in is less than 5, the reverse bias of the diode exceeds a 5 volts. This is minus 5. Minus 5 appear here. This is 0 volts. When it is in open condition, it is in 0 volts. 0 volts. It breaks down. Once it breaks down, you should replace the diode with the cathode positive, anode negative. So cathode positive, anode negative 5 volts. So you are actually adding the 5 volt with the V in, right? V out is nothing but plus minus 5 plus V in. So if you are adding this, y-intercept will be positive 5. And V out is nothing but V in plus 5 if V in is between minus 10 to minus 5, right? Because our limit is at minus 10. So y equal to mx plus c form, again this mx plus c form. Y-intercept is 5. So if you are extending this curve, it will meet at 5 volts y-axis. And slope is anyway 1, M is 1. V out equal to V in, so it passes through -5. And this will be the curve transfer characteristics. Right? Any doubts? ഇത്രയും പറഞ്ഞ കാര്യങ്ങൾ സംശയങ്ങൾ എന്തെങ്കിലും ഉണ്ടോ? ചാറ്റ് വിൻഡോയിൽ പറഞ്ഞ നിങ്ങൾ ഡൗട്ട്സ് ഉണ്ടോ, സംശയങ്ങൾ ഉണ്ടോ? ഡൗട്ട്സ് ഉള്ളവർ അൺമ്യൂട്ട് ചെയ്ത് ചോദിച്ചാൽ എന്തെങ്കിലും ഇഷ്യൂസ് ഉണ്ടോ? Zener diode acting as a tripping element in the circuit. Right. Issues ഒന്നുമില്ലാന്ന് കരുതുന്നു. Right. Okay. Now, to understand the properties of Zener diodes better, let us place two Zener diodes like this along with the resistor. Or again, my input is, let us assume 10 sine omega t. And I'm assuming equal breakdown voltages. We said, or I will assign unequal values. We said 1 equal to 5 volt. VZ2 is equal to, let us take 3 volts. This is my diode 1, diode 2. And this is my output voltage. You are asked to identify or plot the transfer characteristics of the given circuit. As I said earlier, once you are clear with the transfer characteristics, you can easily plot the output waveform. And input is varying between +10 and -10. Right? So how to identify the operation of the given circuit? Let us take a case with a positive input first. No problem if you are assigning negative input first, no change at all. But let us go for a positive input signal. When V in, I'm calling it as V in signal. V in is equal to 10 sine omega. V in is equal to 10 sine omega. If V in is positive, greater than 0, what would the conditions of diode D1 and D2? When V in is greater than 0, D1 operating in forward biased mode because its anode voltage is positive and act as a short circuit. Once D1 is forward biased or short, that positive voltage appearing at the cathode of your second diode, cathode positive. Of course, if this branch is open, output is at 0 volts because no drop across R. 0 volts at anode, positive voltage at cathode, D2 will be in reverse biased mode. If that V in is less than 5 volts, V in is less than 5 volts. Of course, D2 will be in reverse biased mode, but before breakdown. When V in is between 0 and 5, V in is greater than 0, less than 5, right? So.
5 ಅಲ್ಲೋ 3 ಅಲ್ಲೇವರಾ?
All right, sorry. Right, 3 volt. Correct answer. Sorry. We said 2 was, right, sorry. We said 2 was 3 volts. Then if Vin is greater than 0, right, and less than 3 volts, that is correct. 3 volt. So Vin is greater than 0 and less than 3 volts. D1 forward biased, D2 is reverse biased before breakdown. So before breakdown, you should replace your D2 with an open circuit, right? So if your Vin is between 0 and 3, 0 and 3 here, positive. D1 is short circuited, D2 is open circuited. So there is no current to the right, no current to the left, no current through R, no drop across R. V out will be 0. So in this region, V out will be 0. Is it clear? D1 forward biased, D2 reverse biased before breakdown, open circuit. So V out is equal to 0. The moment Vin crosses 3 volts, D1 remains in forward biased, no change because it was connected like this. Its anode voltage is going up, so it will stay in on state, short circuit, not changed. Whereas the reverse bias of D2 diode now exceeds 3 volts, and that 3 volts is the breakdown voltage required for diode D2. And diode D2 was connected like this. Right. So once Vin crosses 3 volts, Vin is greater than 3 volts. D1 stays in on state short circuit, whereas your D2 will breaks down with a potential cathode positive, anode negative of 3 volts. So you're actually subtracting 3 volts from 10 sin omega t. Negative positive 3, you're subtracting 3 volts from 10 sin omega t. And our upper limit is 10 volts here. So I'll write 3 to 10. Vin is between 3 to 10. No change in D1 status, forward biased. But D2 is in reverse breakdown mode, RBB. Reverse biased and breakdown. And V out is nothing but Vin minus 3. Vin minus 3. Here V out was equal to 0. V out was equal to 0. So if Vin is greater than 3 and less than 10, V out equal to Vin minus 3, Y equal to Mx plus C. So Y intercept is at minus 3, slope is 1, so curve will be like this. Clear? Okay. Let us take the other cycle, negative cycle. My diode was connected like this. So here we are about to draw the waveform. So up to 3 volts, V out equal to 0. V out is equal to 0. V out is equal to 0. Right? Okay. 3, 0. 0 to 3 volts 0. Another region 0 to 3 it is 0. Right? This two intervals 0, 3 intervals. Right. If it is greater than 3, V out is nothing but V in minus 3. So at 3 volts, 3 minus 3 you will get a 0 here. Right? 0 there. And a 0 here because this 3 minus 3 is 0. If you are concentrating on the peak instantaneous value 10 volts, 10 minus 3 is nothing but 7. So shape will be sinusoidal with a positive amplitude of 7 volts. Shape will not change, give you sinusoidal shape as such. Right, let us concentrate on negative half cycle. If Vin is negative, if Vin is less than 0, negative, your D1 will be in open condition because its anode is negative. Once this is in open condition, no current through this branch, no current through the output side because output is open. Voltage across R will be 0 because current through R will be 0, implies V out is equal to 0 volts. And that V out equal to 0 volts will continue up to a reverse voltage, a negative voltage, at which the status of first diode changes, D1 changes. And I have connected my D1 like this, anode, cathode. If this voltage exceeds, or that magnitude exceeds minus 3 volts, sorry, minus 5 volts, 5 is the reverse breakdown voltage, minus 5 volts, and D1 is reverse biased, but that breaks down. That will breaks down. And what about the status of D2? When Vin is negative, this breaks down. Your D2 will be in forward biased condition because D2 was connected like this. Right? So up to 5, minus 5, your D1 is off or open or simply in reverse biased mode. And open implies V out will be 0. When Vin goes less than minus 5 or exceeds the reverse voltage 5 volts in the negative direction, your VZ1 breaks down and D2 will remains in on state because you are increasing the negative voltage or increasing the value of voltage in the magnitude of voltage in the negative direction. You are actually making this is even very less, more negative. So this diode was connected like this, cathode was appearing here, so this will remain in short circuit mode or closed or on state. Here it will be open first, so we got 0 output. Now it will breaks down. Once it is in breakdown mode, your cathode will be positive. You should be take care about this. Cathode will be positive, anode will be negative, and breakdown voltage is nothing but 5 volts. Here actually you are adding 5 volts with V in to produce a V out. So if V in is less than 0 and greater than minus 5, your D1 is reverse biased, no change for D2, it is in forward biased mode. And we got output as 0. If V in is less than minus 5 and greater than minus 10. The status of D1 will become from reverse bias, reverse breakdown mode. So this is actually reverse before breakdown when Vin is greater than -5 and less than 0. When it is between -10 to -5, D1 reverse biased and it is in breakdown mode. So I will write reverse breakdown or VR. Here it is reverse before breakdown. Once it is in breakdown mode, you are replacing with an voltage source with a cathode positive, anode negative. So Vout is nothing but, in this case, here it was Vout equal to 0 volts. Last case, Vout is equal to V in plus 5, and you should be take care Vn is negative. So y-intercept is plus 5. So this is positive 5. Initially it was -3. And slope is nothing but 1 itself. So it will is. So slope is equal to 1. Input is negative, output is also negative. So slope is nothing but equal to 1. So its characteristics will look like a 0 volts here. And output increases as input crosses -5 and 3 volts. These two levels are magnitudes are corresponding to breakdown voltages of the respective diodes. Right? So here also we'll have a reverse direction. My level is nothing but 5. So up to 5, it will be 0. 0 here corresponds to this level, and if that value is greater than or less than -5, because -5 level is this one, -5. So this region in between these two lines, I have an input that is less than -5, goes up to -10. So after that I will have a 0. After that it is nothing but V in plus 5. But you should take care that V in is negative. You are adding 5 means your amplitude will get down. So -5 plus 5 will be 0. Here also -5 plus 5 will be 0. Here if you are taking a positive peak, sorry, negative peak, -10 plus 5 is nothing but -5 with that sinusoidal shape. So in this example, output is between +7 and -5. So maximum value of the output is +7 volts, minimum value is -5 volts. And output is equal to 0 for a range -5 to +3. -5 to +3. That you can observe here. This is +3 and this is -5. During the entire range, Vout is 0. So this is the transfer characteristics of the given circuit. It is a series circuit, series clipper circuit. It clips or attenuates the respective amplitudes by 10 to 7 and -10 to -5. And those portion in between 3 and 5 is clipped off. This portion is clipped off. No voltage is present at the output side between -5 to +3. All those range of voltages are clipped off or removed at the output side.